Welcome Matrix, this is Tulu and I'll be looking at the grade 12 term 1 test revision. Some of you have already written the test. You're approaching your first holiday, so hopefully if you didn't do well during the first term test, you can have a look at this as a means of practicing. Some of you are still to write your term test, so let's see what we can do to help you to prepare. Don't forget to like our videos and also subscribe to our channel. And let's get to it. So, question 1. We are going to solve for x. Alright, this is where you should be accumulating your marks. Alright, and what are we going to do first? Well, please do not say x is equal to 5 and then x minus 4 is equal to 5. Although you can, technically, but let's just remove the brackets and then make sure that we can actually work it out. But let's see. If we were to say x is equal to 5 and then x minus 4 is equal to 5, would we actually get these answers? But like I said, let us multiply it out and then we can see from there. So we have x squared minus 4x, and we're going to take the 5 on the right hand side to the left hand side, which will give us minus 5. And then we need to factorize. Okay, for some of you who are not comfortable with factorizing, even though this is just 3 marks, you are more than welcome to use the quadratic formula just to be safe. But for those of you who feel comfortable with factorizing like this, you can tell yourself, okay, 5 is a prime number, so the only factors are 1 and 5. Now you need to decide how are you going to get minus 4. Well, if you say minus 5 plus 1, you will get minus 4. Okay, so therefore, we would say x is equal to minus 1 or x is equal to 5. So you would have gotten 1 mark if you said x is equal to 5, but this one, this one is wrong. So please do not try doing this calculation like this. Rather, remove the brackets and then work from there. Alright, 1.1.2, so we have 4x squared minus 20x plus 1 is equal to 0. Now, as soon as they say correct 2 decimal places, you know that the normal factorizing will not work. So please, in this case, use your quadratic formula. I think it's given in the formula sheet. So we have x is equal to minus b plus minus, then we have b squared minus 4ac. The more you use it, the more you are more likely to remember it. Okay, so what is b in this case? We have minus 20. Please don't forget that this minus b came before, okay? So don't neglect the negative 20 inside the brackets. Alright, so we have negative 20. That's why brackets are so important. Minus 4, a is 4, and c is 1. And then all of that is under this big square root. And that's divided by 2 times 4. Now at this point, please just go ahead and use your calculator. Don't try to work it out in your head. You might waste time. Alright, so let's go. Minus 20. I'm going to start with the positive portion. So I have minus 20 squared minus 4 times 4 times 1. Okay, I'm not using brackets because I see that I don't have any negative value. So I have a number that I can round off to 2 decimal places. Alright, so we get 4,95. Okay, so x is equal to 4,95, or x is equal to, if I use the negative portion of it, I get 0,05. Okay, then I am happy and we can move on to another question. So we have 1,1,3. We have an inequality. So 2x squared minus 2 is smaller and equal to 3x. So what we do here, we need to work out what the roots are. Okay, let me take 3x to the left hand side. So I have 2x squared minus 3x minus 2 smaller and equal to 0. So even here, I can use the quadratic formula, okay, or I can factorize. It's really up to you, really, what is the simplest. Okay, so I'm just going to go ahead and use the quadratic formula. So I know that x is actually equal to, so I'm trying to get the roots here, minus b, so my b is minus 3, plus minus, okay, minus 3 squared, minus 4ac, which is minus 2, and all of that is over 2a. Okay, so 2 times 2. All right, so x is either equal to or x is equal to. So let's go ahead and use our calculators again. Okay, so now we have minus 3. And then we're starting with the positive portion. So plus negative 3 squared. And then minus 4 times 2 times negative 2. Ooh, forgot the negative, the 2. All right, and divided by 4. All right, so we get x is equal to 2, or x is equal to, if I use the negative portion, negative a half. All right, so yeah, we have 2 and we have negative a half. Now, yes, okay, we have 2 or negative a half. Now, let's see. If I were to draw this parabola, this quadratic function, okay, it's a smiley face parabola. All right, yeah, the lines could be better. Let's do better. So you have your quadratic function over there. And then we have negative a half, and we have 2. All right, and because it's included, it said smaller or equal to. Now, if it was, yeah, so we have smaller than. If it's smaller than, it means we're looking at values over here. If it was bigger than, we would have been looking at values here, over on top of the x-axis. Okay, now if it's below the x-axis, you are going to look at the shaded portion inside. All right, if it is above the x-axis, then you're going to look at this portion over here. But anyway, we're not looking at above, we're looking at below. Let's also just remove that so that we do not confuse ourselves. Okay, so then if you are shading in between, that means x lies in between negative a half, okay, and it's included as well, and 2. All right, I hope it makes sense. Now we go to 1.2. We are gliding so far with the maths, with the question 1. Okay, so it says consider, so we have 3 to the power 6x minus 9. And that's equal to 27 to the power y. Okay, and what do we also have? We have x squared plus 5xy plus y squared, and that is equal to 15. Now 1.2.1 says show that y is equal to 2x minus 3. All right, so I am going to leave this sum with the base 3, and I can see that 27 can also be written as base 3. Okay, 3 to the power 3 is 27. And if my bases are the same, I can make my exponents or the powers equal to one another. So I have 6x minus 9 is equal to 3y, and if I divide by 3 throughout, I can then say y is equal to 2x minus 3. Is that what they wanted to see? Yes. So I can move on to 1.2.2. Now it says, hence, solve for x and y simultaneously. So we've written our formula in terms of y. We can go to the second equation. Okay, we can say this is our first equation. Or let me just put it like this. Y is equal to 2x minus 3. That's the first equation. And our second equation, x squared plus 5xy plus y squared is equal to 15, and that is my second equation. So how about I substitute my first equation into my second equation, and let's see where that takes us. So we can then say x squared plus 5x multiplied by 2x minus 3 plus y squared. Oh, don't forget the y. No. What am I doing? What am I doing? So I already substituted the y, which is 2x minus 3, plus y squared, which is plus 2x minus 3 squared. And that's equal to 15. So let me go ahead and simplify. So I have x squared, and if I multiply these two, I'm going to have 10x squared. And these two, I'm going to get minus 15x. And then I'm going to square these. So I have 2. Let me put it like this so that it becomes easier. And let's take the 15 to the other side. All right. So I already have x squared and x squared. Let me just say 11x squared minus 15x. And then I start 2x times 2x, that is 4x squared, minus 6x minus 6x will be minus 12x, plus 9 minus 15, that's 0. So I have 11 plus 4, which is 15x squared. And then I have minus 15 minus 12, that should be minus 27x. And then plus 9 minus 15, that should give me minus 6. All right. And now we need to solve for x. My goodness. Okay, so we can either go the factorizing route, or we're going to use our quadratic function. I would say use the quadratic function, but I'm so tempted to use my factorization over there. So the factors of 15, I have 3 and 5. I have 1 and 15. Okay, factors of 6, 1 and 6, 2 and 3. Let's see which ones would work. What would give me 27? Okay, I'm thinking almost immediately. If I use, let me start by using the factors of 5 and 3. This is also the not so nice thing about this is it's a trial and error. All right, so if I were to use 5 and 3, then what would give me 27? If I were to say 6 times 5, hear me out, 6 times 5 gives me 30. If I subtract 3, then I get 27. So how about I do this? Okay, and we can always check. So if I multiply this, I'm going to get 15x squared, then 3x, then 30x. So I should put a negative 6 over there and a positive over here. Like I said, guys, it's always safe to use the quadratic formula. So please use that just to be safe. Okay, so there we go. We have our factorized values. Now we can say 5x is equal to negative 1, or we can say 3x is equal to 6. So x is negative 1 over 5, or if we divide by 3 both sides, x is equal to 2. But we're not done. Remember, we're supposed to solve for x and y. Now remember, we have our equation. Y is equal to 2x minus 3. So y is equal to 2x in this case. X is negative a fifth. So 2x minus 3. Or y is equal to 2x minus 3. So I have negative 2 over 5 minus 3. I'm going to definitely use the calculator to save time. And here I have 4 minus 3, which is just 1. Okay? Y is 1 if x is 2. And then what about this one? So I have negative 2 over 5 minus 3. So that's just negative 3, 4, or we could say negative 17 over 5. Okay, sometimes fractions are preferred than decimals. And then, yeah, we're done with 1.2. Now let's go to 1.3. Alrighty, 1.3. Show that the roots of 3x squared plus k plus 2 times x is equal to 1 minus k are real and rational for all values of k. Let's just write it down. 3x squared plus k plus 2 times x is equal to 1 minus k. So they are real and rational. Alright. As soon as you hear that, real, rational, unreal, irrational, etc., think about the discriminant. What is the discriminant? Well, basically that is b squared minus 4ac. Remember, it comes from your quadratic formula. Okay, so that is the expression under the square root of your quadratic formula. And the discriminant, it basically tells us the nature of roots in a quadratic equation. Okay, so like I said, we can have real. If roots are real, then we can say that the discriminant is bigger and equal to 0. If they are non-real, we say they're less than 0. If they are equal to 0, we say that we have equal roots. If they are bigger than 0, we say that the roots are not equal. And if the discriminant is basically the square of a rational number, okay, rational, we represent rational with a Q. Rational number, then then the roots are rational. And if the discriminant is not the square of a rational number, then we say that the roots are irrational. Okay, that was a quick reminder of the nature of roots. So what are they asking here? They're asking for it being real and rational. Okay, remember, real and rational. Okay, so real numbers fall under rational. So in this case, what we're going to actually look at is the rational. Okay, that takes precedence. So now, we have b squared minus 4ac, that is our discriminant. Remember, our formula for a quadratic equation is ax squared plus bx plus c. So in this case, our a is 3, our b is k plus 2, and our c, we need to take this c to the other side. Okay, if we take it to the other side, c will be negative 1 minus k. Alright, so let's just rewrite that sum again so that we are sure now of the negatives and whatnot. And we have minus 1 minus k. That's equal to 0. Alright, so now let us work out what the discriminant is going to be. Okay, so in this case, our discriminant is going to be b squared. So we're going to have k plus 2 squared minus 4. A is 3 and c is negative, if I multiply it in, negative 1 plus k. Okay, I hope that was okay. And then let's just continue working it out. Alright, oh, we said rational takes precedence, so this is the square. Alright, so that is what we mean with rational. Remember that the discriminant is the square of a rational number when the roots are rational. Okay. Yeah, actually, it's the square, not the square root. Let me not put the square root over here. It's the square. Okay, so let us solve k plus 2 squared. Okay, that should be easy enough. We get k squared. 2 times k is 2k. And we're going to have 2 of those, so that will be 4k. And then we have plus 4. And then 4 times 3, that's just going to be minus 12. Then we have minus 1 plus k. So let us continue simplifying. K squared plus 4k plus 4. The 12, negative 12 times negative 1, that's positive 12. Yeah. And then negative 12 times k, that's negative 12k. Now we can still simplify further. So 4k minus 8, minus 12k, that is minus 8. I'm already thinking of it in my head. And 4 plus 12, that is 16. So if we were to factorize, I have k and k. The factors of 16, I have 2 and 8. I have 1 and 16. I have 4 and 4. So what will give me 8? 1 and 16 will never give me 8. 2 and 8, it's not going to give me 8. But 4 and 4 can give me 8. If I have minus 4, minus 4. So basically, k minus 4 squared. And like we had said, for the discriminant, all right, if we want rational roots, the discriminant is the square of the rational number. Okay, so the rational number here is k minus 4, and the discriminant is the square of the rational number. So you can leave your answer here. Okay, and then we can go over to 1.4. So it says, if p and q are rational numbers such that the square root of q, or p, plus the square root of q is equal to the square root of 7 plus the square root of 48. Calculate the possible values of p squared plus q squared. Whew, that can be a bit challenging. Like, where do you even start? Alright, so where I would start, I would want to make sure that I have p squared plus q squared on my right. Okay, on the left. So now I only have square root p plus square root q. So what I'm going to do now, I'm going to square. Alright, and keep squaring until I get p squared plus q squared. But now let's have a look. So if I were to square on the left hand side, I basically have square root of p plus square root of q times square root of p plus square root of q. Some of you can do these sums in your head, but I prefer to write it out like this so that I don't forget where I am. And now if you have a square root and square here, they cancel each other. So we have 7 plus root 48. Now if I multiply root p times root p, I just have p. Remember, if you deal with surds, if they multiply, you're going to have something like this. Okay, again, the root and the square would cancel each other. Hence, I'm left with p. And in the middle term, I have root q times root p, which is just root qp. And then I go over here. I also have another root qp. And then multiply there. Sorry, no. I'm doing the same thing again now. Then here we are. Okay, root q times root q, which is simply q. And we're going to make that equal to 7 plus 48, root 48. So now I'm going to put p and q together. I have p plus q, and then I have 2 root pq. I'm just going to put it in alphabetical order. Root pq. Okay, and that's equal to 7. Now, root 48, I can rewrite it. If we were to put root 48 over here, it's 4 root 3. But here's the thing. I want to rewrite it such that I can have 2 outside. Okay, remember 48 is basically 12 times 4. Okay, and if I have 12 times 4 in here, then I can rewrite it. The square root of 4 is 2. So if I take it out, I hope you're following here. So I have 7 plus 2 root 12. And you can check. So if I have 2 root 12, it's going to be the same. 4 root 3. Okay. Why am I doing that? So this calculation it can go, or it can get very tricky. If I decided I'm going to square, I was going to get a very messy answer. It's going to take me a long time. Okay. So what I'm doing now, I want to see how I can relate the left to the right hand side. So the left hand side, I have a p plus q. I can say that is equal to 7. And then I have a 2 root pq, and I can equate that to 2 root 12. Okay, you are allowed to do that. It is allowed. Okay, so I can say p plus q is 7, and 2 root pq is equal to 2 root 12. And in that way, I have two equations and two unknowns. Okay, so the 2's will cancel, the roots will cancel. So basically, p times q is equal to 12. All right, then I can write it in terms of q. I could say p is 12 divided by q. It's my first equation, second equation. So we can substitute the first equation in the second equation. And I know what p is, which is 12 over q plus q is equal to 7, and I multiply by q throughout. So 12 plus q squared is equal to 7q. I'm going to bring 7q to the left-hand side, and I'm going to write it in order. So q squared minus 7q plus 12 is equal to 0. What are the factors of 12 that can give me 7? Well, if you're not sure, write them down. So 2 and 6, 3 and 4. 1 and 12, no. 2 and 6, 3 and 4, definitely. If I say minus 3 minus 4, I will get minus 7. So basically, q is equal to 3 or q is equal to 4. And once I have q, remember p is 12 over q. So p is 4 when q is 3, and p is 3 when q is 4. Okay, so what is the question here? They wanted the values of p squared plus q squared. So what is p squared plus q squared? If I take this side, so I know p is 4 and q is 3. Okay, so I have 16 plus 9, and that is 25. If you decided to take this side, you realize that it's actually the same. Okay, I have p as 3 and I have q as 4, and it's the same. 3 squared is 9, 4 squared is 16, 9 plus 16, that is 25. So basically, p squared plus q squared is 25. And that ends it for question 4. Sorry, question 1.4. But question 1 in general, this is where we ended off. And we're going to now look at question 2. Alright, now we're going to start with question 2. It is given that the general term of a quadratic number pattern is 2n squared plus bn plus 5. And the first term of the first difference is 2. So basically, I'm just going to put there the first 4 terms. We don't know what they are. Sorry, we don't know what they are. And then, so this is going to be t2 minus t1. That's t3 minus t2. And that's t4 minus t3. Okay, and they tell us that the first term of the first difference is 2. So basically, t2 minus t1 is 2. All right, and then here we're going to have the common difference. I'm just going to put it there as D. This is our quadratic pattern. Now 2.1, for 2 marks, it says, show that B is negative 4. All right, so we could do it 2 ways. If you've watched our lesson on patterns, all right, so if you look at the first diagonal, you would know that to get D, you're going to say 2A is equal to D. If you want to get the first term of the first difference, that's basically going to be 3A plus B. And then to get the first term, you're going to say A plus B plus C. All right, so what we do know, then 3A plus B is actually equal to 2. Okay, and what is A? Remember our quadratic equation, it's basically an squared plus bn plus c. So we can see that a is actually equal to 2. So we can say 3 times 2 plus b is 2 and then b would be 2 minus 3 times 2, which is 6, and therefore b would be equal to negative 4, as they have said we should show. All right, otherwise what you could have done, like I had initially put there, we know that the second term minus the first term is going to equal to 2. So if I put 2 everywhere where we have n, I would then have 2 times 2 squared plus b times 2 plus 5, and then minus t1. So wherever there's n, I'm going to put 1. So 2 times 1 squared plus b times 1 plus 5, and that'll be equal to 2. Ooh, I didn't calculate the space there. Alright, so anyway, 2 squared is 4, and 4 times 2, that would give me 8. So I have 8 plus 2b plus 5 minus 2 plus b. Ooh, actually, let me do this. Put brackets. Very, very, very important, or else, yeah, things go wrong. So, minus 2 minus b minus 5, and that's equal to 2. So let us just simplify. Okay, it's a little bit skew. Let's just work it better. So I have 8 plus 5, that is 13, minus 2, that is 11, minus 5, I get 6. And then you have 2b minus b, that's basically b, and that's equal to 2. Now I have 2 minus 6, so b is minus 4. All right, 2 ways to do it, and you get to the same answer, and it's 2 marks. So you'll decide which one is easier, quicker. You don't want to waste time. So now it says determine the value of the 100th term of this number pattern. So now you have your full quadratic pattern, all right? So it's 2n squared minus 4n plus 5. Even if you couldn't solve b or show that it is equal to negative 4, going forward in the questions, please use negative 4. They gave it to you. So we're looking for the 100th term. So basically t100. Okay, wherever we have n, we're going to substitute 100. All right. And now let's just work it out. So we have 2 times 100 squared. It's going to be a very huge number. Minus 4 times 100 plus 5. And we get a number of 19,605. So that's just 2 marks. Rightfully so. Nothing complicated there. Now 2.3 says determine the general term for the sequence of the first difference of the quadratic number pattern. So basically, what do they want? They want the general formula for this, the first difference. And the first difference is normally your arithmetic pattern. All right, so what do we know? We know the first term for the arithmetic pattern, A. We know that it is 2. It was given to us. Okay, how many marks? It's 3 marks. So what we can do, we can go look for 2 other terms. Okay, so we know this is T1. What would T2 be? Okay, we go back to our formula. Instead of 100, we're going to put 2 because we're looking for the second term. So we get our second term to be 5. And then what would be our third term in the quadratic pattern? So actually, let's get the first 4 terms. Okay, so it's 21. And then wait, did I just put the 4th term? Okay, I calculated the 4th term. Here I am thinking I'm calculating the 3rd term. Okay, so that's T3. Now T4 is 21. Let's go get T3. Okay, so that's 11. So we have 2, 5, 11, 21. Let's get the first difference. No. What am I doing? Term 1 is not 2. That is the first term of the arithmetic series. Okay, So yeah, so term 1 is actually 3. We know this to be 2. Okay, and then 11 minus 5, that is 6. 21 minus 11, that is 10. And then our common difference, 6 minus 4, 6 minus 2 is 4, and 10 minus 6 is 4. So I'm already thinking ahead. All right, so we have then A, right? A is 2, okay, and D is 4, all right? So now, before we put it in the form TR is equal to SR plus U, I would advise first you put it in the way that you know it. Then you can translate it to how they want it. All right, we said the first term is 2, and then we have n minus 1, and the difference is 4. So we have 2 plus 4n minus 4, and therefore we have 4n minus 2. Okay, so therefore we have TR is equal to 4R, okay, because it's R there, they're not using n anymore, and then minus 2. So that is it. And now the last question from question 2, 2.4. It says, which two consecutive terms in the quadratic pattern have a first difference of 1118? Okay, so let's go back to our quadratic pattern. So we had or have 3, 5, 11, and 21, right? So the first difference there is 2, and then you get 6, and then you get 10. So somewhere there are some two consecutive terms. Okay, so there'll be term number, I don't know, maybe term number 30. So I'm just going to put Tn, and 31, Tn plus 1. This is me just making an example. And they tell us that the first difference between these two consecutive terms is 1118. Now they're asking, what are those terms? So this question, I see it a lot. Please make sure you understand it, practice it. It might come out sometime during the year. All right, so what we're going to do, we're going to say this Tn plus 1, if I subtract Tn, I will get 1118. So I'm going to take my quadratic formula. Hope you still remember it. There it is. And wherever I see n, I'm going to substitute n plus 1. So basically, I'm going to have 2 n plus 1 squared minus 4 n plus 1 plus 5. And then I'm going to subtract Tn. So basically, 2n squared minus 4n plus 5. And all of that is equal to 1118. There can be room for a lot of error. So just be careful and take your time. So 2 times n plus 1 squared. So basically, inside the bracket, we're going to have n squared plus 2n plus 1, then minus 4n minus 4 plus 5 minus 2n squared plus 4n minus 5. I'm going to bring the 1118 to the left hand side. So we have 2n squared plus 4n plus 2. I'm going to leave everything for now so that I can cancel ones. Okay. So what do I have here? So I have 2n squared, and I can subtract the 2n squared. There's 4n. I can subtract the 4n. There is 2. Okay, let's leave that for now. I have 5 and a minus 5. So basically, I'm left with 2 minus 4, and then I have 4n. Maybe I should have left the 1118 to the other side. So 2 minus 4, that is minus 2. So basically, I have 4n minus 2. I'm going to take that 1118 to the other side. And then we have 1118. I hope I didn't miss anything. So now for n, if I take 2 to the other side, I have 1120. So if I divide by 4, both sides, what am I going to get? So 1120 divided by 4, that's 280. So n is equal to 280. So between which two consecutive terms do we have the first difference of 1118? Basically, it will be term 280 and term 281, because we had tn and tn plus 1. All right, so this is really not bad, and I hope you will never forget how to do this kind of question. Okay, so that's it for question number 2. All right, let's look at question 3. All right, so we have 3.1. While we're at it, please don't forget to like our videos as well as subscribe to our channel. So we have the sequence given, 3, 5, 7. You can already see we just keep adding 2 to get to the next term, right? And now for 3.1.1, it says determine the general term. All right, so we have our formula Tn is equal to A plus n minus 1 times D. We already know that D is 2, positive 2, and A is 3. All right, so let's just substitute what we know, and this is for 2 marks because this is pretty much straightforward. All right, and D is 2. So we're going to have 2n minus 2 plus 3, which then becomes 2n plus 1, right? Whenever you are done getting your term formula, test it. If you were to put 3, we're expecting to get 7. So 2 times 3 is 6, plus 1 is 7. Term 2, 2 times 2 is 4, plus 1 is 5. So we are confident that our term formula, or general term formula, is actually correct. Now 3.1.2 says calculate the sum of the first 40 terms. So you're going to use your sum formula. All right, it's there in your formula sheet. I just happen to remember it, which saves time if you do know it, but please just make sure that you always check. All right, so we're looking for the sum of the first 40 terms. So in the place of n, we're going to put 40. All right, the first term is 3, and we're going to say 40 minus 1, and D is 2. So you can just plug all of this into the calculator. I'm just going to simplify it a bit. So we have 6, and then 40 minus 1 is 39. 39 times 2 should be 78. Okay, so basically I have 20 times 84. 78 plus 6. Okay, let me grab my calculator. And yeah, what is 20 times 84? It's basically 1680. Like I said, in this step you can already put everything in the calculator just to avoid making silly mistakes. Okay, yeah, and now let's go to question 3.2. So 3.1 was very easy. Now, sigma notation. I don't know what it is about sigma notation that makes people a little bit uneasy. It's really nothing to be scared of. Please do not become scared of this. So it says evaluate. All right. What I normally do when I deal with sigma notation, in terms of evaluating, firstly I want to determine what kind of sequence do I have. Is it geometric or is it arithmetic? Now, because k is not an exponent, I know that it is arithmetic. Okay, and because it is arithmetic, I just want to get the first 3 terms. Okay, because this is what sigma means. Sigma means we have the sum. okay, from term 2 up until term 100. So I'm looking for the number of terms. I'm simply going to take the value on top minus the value at the bottom plus 1. We always add 1. Please do not forget that. So 100 minus 2 is 98 plus 1. It's basically 99. So I have 99 terms. So I'm basically looking for the sum of 99 terms. Okay, and this is an arithmetic series. So it'll be n over 2. Remember, we have our formula there, so I don't need to rewrite it again. So it'll be 99 over 2. And then I need to go get the first term. That's why I want to get at least the first 3 terms. And why is that? I want to get the value of A as well as the value of D. So let's go ahead and get the first term. So the first term, 7 minus 2k. So in the place of k, I'm going to put 2 because that's where it starts, with 2. So basically that'll be 7 minus 4, which is 3. Then term number 2, I'm just simply going to substitute the next term, which is 3. All right, so 7 minus 6, that'll be 1. And then the third term will be 7 minus 2 times 4. We just keep adding 1 as we go along. So 7 minus 8, that'll be negative 1. So I can see then that every time this sequence, it reduces by 2. So I have D. All right, and I have A. So that's great. Now I can go to my sum formula because we are summing. Okay, that is what the sigma notation stands for. It's the sum of. It's just a simplified way of writing it. Okay, let me just put it like this. So we have k equal to 2 and then 100. Okay, so we basically have everything that we need, right? So 2 times A, which is 2 times 3, plus 99 minus 1 multiplied by D, which is negative 2. Ooh, didn't calculate space over there. So the sum of the first 99, oh, not really the first 99 terms, it's just the sum of these 99 terms. I'm just going to put everything in the calculator as it is so that I don't complicate my life. And then I have 2 times 3, which is 6. Okay, I said I'll put it as it is. Let me put it as it is. Okay, 99 minus 1 multiplied by negative 2. And I need to make sure I close that bracket. Okay, so what do I have? I have negative 9,405. And we are expecting a negative number because as we go along, because D is negative 2, we keep getting negative numbers. Okay, that's basically that. That's it. Important thing, get your N, get your A, get your D if you're dealing with an arithmetic series, get your R if you're dealing with a geometric series. Okay, so that's 3.2. Now let's have a look at 3.3. It says, for which values of x will this entire sum be a converging series? Now in this case, you need to remind yourself, what are the conditions for convergence? All right, let's see if we have a formula sheet here. Okay, so for convergence, remember whenever we deal with converging series, we're dealing with sum to infinity. Okay, and what are the conditions? They're not asking for the sum to infinity. They're just basically asking for the value of x. So converging series, basically you have your common ratio that is in between -1 and 1. All right, that is the condition. Now let us go and get what R is. What is R? Okay, so our first term, term number 1, is basically x. Term number 2 is x times x minus 1 over 2. Term number 3, what is it? It's x. And then we have x minus 1 over 2, and that is squared. So if I were to look for R, okay, R would be term 2 divided by term 1. So what is term 2? It is x, and then I have x minus 1 over 2, and what's term 1? It's basically x. Okay, so r in this case is x minus 1 over 2. Just to make sure, I know that r is also term 3 divided by term 2. I just want to be sure, okay? Let's just be certain that r is basically the same. So now we have x minus 1 divided by 2. That's term number 2. So the x's cancel. This cancels and that cancels. So we're basically left with x minus 1 over 2. So we are confident now. R is x minus 1 over 2. And what are the conditions? Basically we had that r is in between minus 1 and 1. So r, in the place of r, we're going to put x minus 1 over 2. What am I putting there? That should be negative 1. Okay, so I don't like fractions. I'm going to multiply by 2 throughout. So then I'm going to have negative 2, x minus 1, 2 over there. And then I'm going to take minus 1 to the other side, which will be a plus 1. So that will be 3. Then I'm going to take minus 1 to that side. It's going to be a plus 1. Minus 2 plus 1. That's simply minus 1. And that's it. Basically, when it says for which values of x will this be a converging series, values that are in between negative 1 and 3. I hope that was well understood. This is a nice revision while you're on holiday. Okay, and now we can go over to question. So question 4 reads as follows. Data regarding the growth of a certain tree has shown that the tree grows to a height of 150 after 1 year, so 150 centimeters. The data further reveals that during the next year, the height increases by 18 centimeters. In each successive year, the height increases by 8/9 of the previous year's increase in height. The table below is a summary of the growth of the tree up to the end of the 4th year. Alright, so you can see first year, the height was 150 centimeters. Then second year, the growth was 18, meaning the height of the tree was 168. And then for us to go from 18 to 16, we had to multiply by 8 over 9. Okay, let's just check. So we have 18 multiplied by 8 over 9. And there we have 16. All right. And from 16 to 128 over 9, I presume we also have to multiply by 8 over 9. So you can see here, since we're still at patterns, you can see that this is a geometric pattern. All right, and after we get that value, we can see we had to take 150 plus 18 to get 168, and then 168 plus 16 to get 184, and then 184 plus 128 over 9, that gives us 1784 over 9. So that's basically what's happening there. All right, now let us look at the questions. So 4.1 says determine the increase in height of the tree during the 17th year. So the increase in height, that's basically the growth. Okay, so we need to find out the growth for the 17th year. And since we have established that this is a geometric pattern, this is the equation that we're gonna look at. Okay, so T17, A would be 18. The common ratio, that would be 8 over 9. And then in the place of n, we have 17 minus 1. Okay, so at this point, I would just plug everything into the calculator. Not try to calculate anything by head, lest I make stupid mistakes. Alright, so that is to the power 16. That's 17 minus 1. Okay, so we get an answer there of 2,73 centimeters. Alright, so on the 17th year, that is the growth, all right, or the increase in height, and that you get your 2 marks. Okay, now it says calculate the height of the tree after 10 years. So they're not asking about growth, but they're asking about the height of the tree after 10 years. Remember, year 1, it was 150 centimeters. Year 2, it was 168 because we added that growth of 18 centimeters. Okay, year 3, it was 184 centimeters because we added the 16 centimeters. Okay, yeah, actually, yes, let me just do that. All right, so we had to add 18, there we added 16. And we go on and on and on. So basically, ultimately, what I want to say 150, and I'm going to add, and 150 was for year 1. So how many years are we left with? We are left with 9 years. So I need to sum up all the growths, okay? So the sum of 9 years of growth, that's what I need to do, okay? Or sum up the heights for over 9 years, all right? And therefore you're going to have to use your sum formula for your geometric series. Okay, so let's have a look at the formula sheet just to be sure. Okay, so for your geometric series, we have Sn, then your first term multiplied by a common ratio to the power n minus 1, and we have r minus 1. Okay, let's go back, get the values that we need. So we know we're summing up the growth for 9 years. Okay, so our first term, we have it as 18. Our common ratio is 8 over 9. N would be 9 minus 1. And then we have 8 over 9 minus 1. So I would then put that into the calculator as it is and then solve it. So we have 18. Okay, let's put everything in fraction form. Okay, so we have 18, and inside there we have 8 over 9, and that's to the power 9, and we are subtracting 1. Okay, let's just say minus 1. And then in the denominator, again, we have 8 over 9. Okay, 8 over 9 minus 1. Okay, so again, we get, so the sum of all those growths, or the sum of all those heights over the 9 years would be 100. I'm going to round it off to 2 decimal places. That's always safe to do. So it's going to be 105.88 centimeters. All right, but that's not the question. They didn't ask for the height or the growth over 10 years. They asked for the height of the tree after 10 years. So the height of the tree, okay, or tree height, is basically that 150 centimeters for the first year plus the growth that it has done over 9 years. Okay, so we have 150 plus 105.88. So we're going to get 255.88 centimeters. Okay, so that is the height of the tree after 10 years. As you can see, as the years go by, it's not growing that much anymore. And then now we get to 4.3. So it says show that the tree will never reach a height of more than 132 centimeters. Okay, where will we start? All right, first of all, we need to determine the sum of all the heights to infinity, because infinity is like that number that, yeah, towards the end, basically further than infinity, you won't really get any growth anymore. So I suggest we get the increase in height or the growth in centimeters, and sum it up, all of them. Okay, so basically that's infinity. So we're going to use our infinity, sum to infinity formula. So that one is a little bit easy. Sum to infinity then would be equal to a over 1 minus r. Okay, so we know that a in our case is 18 and 1 minus 8 over 9. Remember, this what we're doing here, similar to what we did in 4.2, we're getting the sum from year 2 onwards. Okay, remember there's still year 1, because we want to show that the tree will never exceed a height of 132 centimeters. So after getting the sum to infinity, we need to add 150 centimeters. Okay, so there we are. We have 18 over 1 minus 8 over 9. And we see that it's 162. Okay, that is the sum of all the heights, of all the growth. But, yeah, the height of the tree, well, let me just say the maximum height, it's basically going to be 150 plus 162. And what is 150 plus 162? That is 312. What was the question? Okay, I think they wrote this incorrectly. Instead of 132, they should have put 312. So maybe they swapped it. But yes, this number that we have here, the tree will never grow beyond 312 centimeters. Okay, so yeah, it'll never go beyond 312 centimeters. And that's basically it for question number 4. Question 5. Now we're starting with the functions, and I see our function f is basically a hyperbola. All right, let's just have a look at it. So f of x, so you started with the basic hyperbola in grade 10, then started doing some shifts in grade 11. So by now you should be an expert. And if you missed everything in grade 10 and 11, let's hope that you can catch up now in matric. All right, so this is a hyperbola. Firstly, what I notice is that we have a negative value. Okay, so if you have a negative value, remember this line has a positive gradient, and that line has a negative gradient. So if you have a negative value here, it means your hyperbola is going to be in the second and the fourth quadrant, because it is negative. Okay, so that's one thing we are expecting, for it to occupy the second and the fourth quadrant. Okay, and then what else do we know? So we know it's going to occupy these 2 quadrants. And then just by looking at this -1 and 3 over there, I know that my asymptotes are at x is equal to 3 and y is equal to -1. So I'm expecting my hyperbola to do something like that. Okay, so that's what you do quickly. As you see, the function that has been given. Now it says calculate the coordinates of the y-intercept of f. Okay, whenever you calculate the y-intercept, don't forget that you make x 0. So basically y will be equal to -6 over 0 minus 3 minus 1. So let's just simplify that. Y is equal to -6 divided by -3 minus 1. The negatives cancel, so we have 2 if we say 6 divided by 3. And 2 minus 1 is simply 1. Alright, so that is the coordinate. Now let's write down the coordinate. The coordinate is going to be 0 and 1. Okay, So that's basically that. And then 5.2, calculate the coordinates of the x-intercept of f. So whenever we're calculating the x-intercept, we need to make y 0. So let's go. 0 is equal to negative 6 over x minus 3 minus 1. So this is now as solving for x. So I'm going to take negative 1 to the other side. And then I have negative 6 over x minus 3. Then I'm going to multiply x minus 3 on both sides. And what am I left with? I have x minus 3 is equal to minus 6. Then if I take minus 3 to the other side, I have minus 6 plus 3, which is minus 3. But we're not done, actually. This is just the x value. What is the coordinate? Minus 3, 0. And then 5.3, sketch the graph, clearly showing the asymptotes and the intercepts of symmetry. Alright, so I drew it previously briefly, but now let's draw it more accurately. Okay, so that is our x, y, and x-axis. I know that my asymptote, I have x minus 3. So basically, the asymptote is going to be x is equal to 3. So let me just label it. Okay. Yeah, maybe let me make it a bit smaller, the intervals. Alright, so there is 3. I'm just going to indicate that that is my asymptote. I can even write there that x is equal to 3. I don't know if they're going to really be concerned about that, but yeah. And then the other asymptote is minus 1. Okay. So there is minus 1. Basically, y is equal to negative 1. Alright, and then I worked out the x and y intercepts, right? So my x-intercept is minus 3. So x is minus 3, 1, 2, 3. So that's negative 3. And then the y-intercept I have forgotten. That is 1. Okay. So it's there by 1. Okay, so basically our graph then, when we sketch it, it's going to do something like this. Okay, that's the first. Oof, actually, let me just draw it freehand. Okay, there it is. Remember, it doesn't touch the asymptote. It tries to touch it, but it never does. And then you have the other portion of it here. So you see it occupies the second and the fourth quadrant. They also spoke about the intercepts of the x symmetry. No, the intercepts of symmetry, not x symmetry. So I'll put it in different colors. And yeah, so basically we're going to have one where we have a positive gradient. It must actually pass here. Okay, so that's one of them, and the other one has to also pass the middle. Okay, those are your axes of symmetry. Okay, so that's basically that. We tried to make it as neat as possible, but I hope you get the gist of it. If you really cannot draw just by the information of your x-intercepts, y-intercepts, and your asymptotes over there, please, on your calculator, use the table function. Okay, go to the table function, put in the equation. Okay, so we have minus 6, and then you have x. So I'm going to say alpha x minus 3, and you have minus 1, and then you started, let's start it at minus 5 and end it at 5. in steps of 1. Then you can sketch your graph. Okay, you'll see at -5 it's -1/4. At -4 it's -1/7. -3 should be 0, yes, because that is the x-intercept. And you can put in the points. Okay, so yeah, at x is equal to 3, of course, we have an asymptote there. We're not expecting any value. Okay, so that is how you can draw it if you're really not sure how to do it. Just like the way I did it. Okay, so where am I? Mode. Alright, doesn't want to go back to the original mode. There we go. Okay, awesome. Now let's go to 5.4. Alright, so it says one of the axes of symmetry of f is a decreasing function. Write on the equation of the axis of symmetry. So the axis of symmetry, we can see those are straight lines, and we know that when you're going down from left to right, then your gradient there is negative. Okay, this is a decreasing function. Okay, this is an increasing function. So we're looking at the one with the negative gradient, and we need to get the equation. What do we need for us to get the equation? Firstly, we need a point, and then we need the gradient. Now, the nice thing about the gradients of the hyperbola, your gradient is either 1 or -1. Since we have a decreasing function, we're going to definitely choose -1. And what point can we use? Well, remember that your axis of symmetry actually crosses where your asymptotes intersect. And where do they intersect? They intersect at x is equal to 3 and y is -1. So you have your point there of 3 and -1. So you have your point, you have your gradient. Now it's very easy to get the equation of that line. So we have y is equal to mx plus c. In the place of y, we have -1. In the place of m, we have -1. In the place of x, we have 3. And we're just trying to solve for c at this case. So we have -1 plus 3. Okay, so c is 2. And does it make sense? Yeah, okay, I didn't draw my thing to scale. According to my sketch, which is definitely not to scale, it's showing the intercept to be there at 4, which is incorrect, but we actually see that it's 2. Okay, so now we can write down our equation, which is basically y is equal to -x plus 2. And that's your equation. And then lastly, 5.5. Alright, so it says, for which values of x is the function bigger than 0? This question dribbles a lot of people. Please do not be dribbled by it. Overcome it. What is it saying? This question is simply saying, where are the y values of this function bigger than 0? Okay? And wherever those y values are bigger than 0, which x values are associated with those y values? Okay, let me show it visually. So we need to go look at the y values of the function f that are bigger than 0. We're going to go to our graph that you drew to scale. Okay, there we are. Choose a different pen. Y values bigger than 0. Remember, 0, y is equal to 0 is here at the x-axis. So basically everything above the x-axis, okay, that's where the y values are bigger than 0. So basically we are here, positive y values. Here, this is exactly at 0. This is at y is equal to 0. But anywhere else, that is y bigger than 0. Now we need to check. Where does it start? Which x values are concerned with those y values? We have the x value of -3. Okay. And then we have the x value of 3. So in between -3 and 3, that's where you get the y values that are bigger than 0. So how are we going to write that answer? Well, we're going to say x is in between 3 and minus 3, right? That we saw. But it cannot be equal to 3 because 3 is the asymptote. So, x is just smaller than 3. And it cannot be equal to minus 3 as well because that is where y is equal to 0. They said the y values being bigger than 0. So we know that x has to be bigger than minus 3. And that is your answer. Okay, and that is it for question 6. Question 6. Sorry, previously I said that was it with question 6, but that I meant to say question 5. Alright, so now we get into question 6. So we have S and T, which are the x-intercepts of the graph. Alright, so our graph is your parabola or quadratic function with a sad face, so A's value is negative. Okay, and A is definitely not 0. And then we have R, that is the y-intercept of both F and G. G is your straight line function or your linear function. Now the straight line through R and T has the equation minus 2x plus D. So they have given us the equation halfway through. We don't know what D is. Yeah, so and then the first question, of course, would be what is the value of D? And it's only 2 marks. All right. So let us see. They've given us the equation. I'm just going to put it in terms of y instead of writing it as g of x. So we have minus 2x plus d. In a case like this, we have 3 unknowns and we're trying to get d. So in this scenario, I'm going to look for another point on the straight line graph. All right, and I see that we do have a point called t. And t is 6 and 0. So I can go ahead and substitute 0 in the place of y and 6 in the place of x. And therefore, I find that D is actually 12. All right. So I can note for myself that actually R is 0 and 12. Okay. Now, let's go to the next question, 6.2. Show that the equation now is equal to negative x squared plus 4x plus 12. We have been given all the intercepts now. Okay, we have S, right? That is minus 2 and 0. We have T, that is 6 and 0. And we have R, the y-intercept, which is 0 and 12. And if you've ever looked at our video on functions, particularly the quadratic function, you'll know what to do when you have all the intercepts. All right, so basically you're going to use this equation. Y is equal to A, and you have x minus x1, then x minus x2. In the place of x1 and x2, you're simply going to put your x-intercepts. All right, so you have minus minus 2, which is plus 2, and you have x minus 6. While we're at it, we're going to then substitute our y-intercept. All right, so in the place of y, we have 12. And in the place of x, we're going to put 0. So now you see the only thing that we have to solve for now is a. And a should be negative 1. If you don't get negative 1, then you have a problem. Okay, so we have 2 times negative 6, which is negative 12. So a is simply 12 divided by negative 12, which is negative 1. So that's great. We are happy. A is negative 1. Now, what are we going to do to get the rest? 4 as well as 12. So now you know that y is equal to negative 1. You don't need to put the 1 there. You can just say x plus 2 and then x minus 6. So you're basically now going to multiply out. Okay, so x times x, that's x squared plus 2x minus 6x minus 12. So that's just simplified. We have x squared, 2 minus 6, that is minus 4, and minus 12. Now we're going to multiply in that negative. Okay, so I'm just going to put there f of x. So I have negative x squared plus 4x plus 12. And is that the equation that was given? Yes, we have shown that indeed f of x is negative x squared plus 4x plus 12. So we are happy. Now let's go to 6.3.1. So it says determine for which values of x will f of x minus g of x be bigger or equal to 0. Okay, so it's basically saying if you take the y values of f and you subtract the y values of g, where do you get positive y values? Okay, another way of looking at it, you can say f of x bigger and equal to g of x. So basically, if I have a look at my graph, where are the y values of f bigger than the y values of g? And this is f, by the way. Okay, so I see the y values of f here are actually bigger than the y values of g in the same region. Okay, over here g is bigger, okay, and f is smaller. Over here again g is bigger and f is smaller. So only in this region that I have indicated, that I've highlighted. And what are the x values there? Basically it's x being in between 0 as well as 6. Okay, so they said where are the y values of f bigger and equal to the y values of g? It is at 0 and 6. So I need to say x is bigger and equal to 0, but x is smaller but also equal to 6. Okay, and that is it for 2 marks. Now let's just make this a little bit bigger. 6.3.2. So now determine the values of x. For which values of x will x, now we're multiplying. It's getting a little bit complicated. So x times f of x smaller than 0. Alright, so in this case, f of x, we have it, it's there. Alright, and they didn't tell us that we should use the graph to get our answer. So what you can do, which could be a little bit complicated, you can go and take your equation for f of x and multiply it with x. And what that will do, you'll now get a cubic function, okay, which makes things a little bit complicated, as I said. Okay, so what I mean is we take x and we substitute in it. We have negative x squared plus 4x plus 12, and all of that is less than 0. So basically if we multiply it out, we have negative x cubed plus 4x squared plus 12x less than 0. Okay, so this has changed the question entirely, and this will require you to know your cubic functions. Okay, so if you have a negative x cubed, your cubic function does something like that. But this is something that we haven't covered yet, so let's try another method. So yeah, we're really not going to go that route of doing the cubic function. What I'm going to show you is a little bit long for 3 marks, but I think you'll understand better. Okay, firstly, I want us to get the critical points before we can determine where x times the function f of x is smaller than 0. So when we get the critical points, let's just say this. Let's get the critical points. Alright, so we have x times negative x squared plus 4x plus 12. And we're making it equal to 0 because we're getting the critical points. So then we have x is equal to 0, or negative x squared plus 4x plus 12 is equal to 0. So there we have one critical point, which is 0. Here we already have our critical points, which is x is equal to -2 or x is equal to 6. Those are our x-intercepts. So we have our critical points, which is -2. Okay, then we have 0. Then we have 6. So what we're going to do now, we're going to take the numbers before and after the critical points. So with -2, we get -3 and -1. With 0, we get -1 and 1. And with 6, we get 5 and 7. Then we're going to substitute it. I know this is long. Bear with me here. Then we're going to substitute these values into this equation, x times f of x. All right. So, for example, we're going to start with -3, then -1, then 1, 5, and then 7. Okay. So with -3, I'm going to have -3 over here multiplied by that -3 squared plus 4 times -3 plus 12. And we are going to get what that value is. Alright, so we have -3 multiplied by negative, and then again we have the -3, and then squared plus 4 times -3 plus 12. So what answer do we get? We get 27. And that is bigger than 0. Then we're going to substitute in -1. Okay, I'm not going to write it down. I'm just going to, do this so that we can get what the answers are and we don't waste time. Again, this is 3 marks. I'm just going about it the long way so that you understand how we get it. Please do comment below if you have a number, or you have a way of doing it much quicker. Okay, so -7, that's less than 0. Then we're going to put there 1, so +1. And then we get 15, so that's bigger than 0. And then we're going to put there 5. So that's the nice thing about not deleting on your calculator but leaving the answer there. So we have 35, bigger than 0. And then lastly we have 7, which comes after 6. And we have a negative number. Alright, what do we do now? So we know that for -3, we get an answer bigger than 0, so that doesn't really apply for us. For -1, we get an answer that is smaller than 0. Okay, again, smaller than 0. So basically between -2 and 0, that's where our solution lies. Okay, for -1. And then for 1, we get positive. For 5, we get positive. And then for 7, we get negative. Okay, so it's less than 0. So where does our solution lie? Well, basically our solution for x lies in between -2 and 0, and where x is bigger than 6. Okay, remember the question? 6.3.2, determine for which values of x will x times f of x be smaller than 0. You could have also written it like this. X is an element of -2. We're going to use round brackets. Okay. And also where x is bigger than 6, from 6 to infinity. Okay. So that is how you're going to do that particular sum. Unless if you guys have done cubic functions already, then by all means you can go ahead and work it out from this point onwards and get to see where this function is less than 0. But if you haven't, you can adopt this method, and if you know a quicker way of doing it, please do comment below so that others can also benefit. Alright, we're almost there. Now we're at 6.4, and it says, given that the graph of f turns at 2 and 16. Okay, so that's the turning point basically, and it is actually to 16. You can work it out if you want to. So now it says determine the value or values of k for which f of x, remember what f of x is? So f of x is equal to k. So f of x is negative x squared plus 4x plus 12. Okay, it's equal to k. We'll have two positive roots. Okay, two positive roots. Currently, I'm just going to redraw this again. Not going to be to scale, but you'll get the gist of it. So currently, this is what we have. Okay, let's just pretend. And over here, we have 2 and 16 as the turning point. So at the moment, we don't have two positive roots. We have one negative root and a positive root. And that negative root is negative 2. And the other root that's positive is 6. So they're asking, this k will be like your vertical shift. Okay. So how can we move this graph vertically such that we will have two positive roots? Okay. So if I shift this downwards, I still have one negative, one positive until I get just past y is equal to 0. Okay, so just getting onto the negative, then it starts being positive. Okay, and it becomes positive until until the turning point is on the x-axis. And at what point will the turning point be at the x-axis? It will be after I've shifted 16 units down. So this is 16 units down, okay, because we come from there. And to get all the way to the x-axis, that is 16 units. But how am I going to get this value over here? Okay, I'm trying to select this parabola, but it doesn't want to select. Yes, there we go. So what is this value here? How am I going to get this particular one? Okay, this is when I have one root as 0. So yeah, how am I going to get to the other one? Okay, because the k values, my answer is going to be, so I need to get this value over here. And how will I do it? Well, basically, I need one of the roots to be 0. And let's go look at this sum over here. Okay, so I know then if I were to factorize this, okay, I already know I'll have minus x and x, and then I'll have 2 and 6. Alright, so I will have x times x, that's negative x squared, maybe minus 2x plus 6, but no, we have a negative in front, so let's just check it out. Negative x squared, negative 2x, negative 6x, so maybe let's have that as negative. Okay, so we have negative x squared, negative 2x, positive 6x, and positive 12. Alright, so we are cool. That is how we're going to factorize over there. And all of that is equal to k. Alright, hence we have our roots there that were x is equal to negative 2 and x is equal to 6. But if I take 12 away, okay, such that we have x squared, because I'm trying to get a root that's going to be 0 and whatever number that's going to be there. Okay, so we have 0 and that number. So if I now subtract 12 on both sides, so I have negative x squared plus 4x plus 12 minus 12, that's 0, and we have k minus 12 there. Okay, so this side, I'm going to take x out, so I'm left with negative x plus 4. So basically, yeah, I'm going to make that equal to 0. So my roots then would be x is equal to 0 or x is equal to 4. So if I shift it down, this will be 0, that will be 4. Okay, and that means I have practically shifted down 12 units. I hope I'm making sense. And so k will have to be in between 12 and in between 16. All right, for there to be 2 positive roots. Okay, or I could say k is an element of, remember we use round brackets, from 12 to 16. And that is it for question 6. Alrighty, question 7, the last question. We are finally there. 7.1, we have f of x is equal to 3 to the power x. So this is an exponential function. It would look something like this, okay, where the y-intercept would be 1. This is y is equal to 3 to the power x. Alright, so if you have this number, I would say a. If it's bigger than 1, then your graph would start from the first quadrant and end up in the second quadrant. Okay, if you were to reflect it about the y-axis, your function would look something like this, and a would be in between 0 and 1. For example, if you had y is equal to a third to the power x. So if it's more of a fraction, it's going to start in the second quadrant, land in the first. Okay. Anyway, let's look at the questions. It's always good to know visually what you're working with. So 7.1.1 says, determine an equation for the inverse function of f in the form f to the power negative 1x. Okay, so I'm just firstly going to write it like this. Y is equal to 3 to the power x. If they want an inverse, then you should know by now that you are going to swap the x and the y. And we need to write it in terms of y. Okay, and if we need to do that, if you have your unknown as an exponent or in the power, you need to bring it down using logs. Okay, so the answer basically will be y is equal to log base 3x. If you want to know the long way of getting it, you would introduce logs on both sides of the equation. So you have log x is equal to log 3 to the power y. And whenever you have logs and there's a power there, you can bring down the power. You can bring down the exponent. So you have y times log 3. And then I'm going to divide by log 3 both sides. So then I have y is equal to log x over log 3. Okay, this is technically correct. You can leave it like this, but I don't think for the purposes of getting the full marks you'll get it, even though it's only 1 mark. You can take it a step further by saying in your denominator, this is your base. So you'll have log, all right? Your base will be the 3 and your numerator will just be the x. Okay, so that's a long way of getting it. But yeah, even though it's long, at least you know how to get it. Now it says, sketch the graph of the original function and its inverse in your answer book. Okay, so I already kind of gave you an idea of how the original function will look. Now let us just draw it all together. Okay, so the original function will look something like this. Ooh, that arrow. Okay, so that's basically f, right? And that would be y is equal to, or f of x is equal to 3 to the power x. Now, in order for you to get your inverse, you need to draw your line y is equal to x, because your inverse is always symmetric about the line y is equal to x. Okay, let's just shift it a little bit so that it goes through the origin. Okay, this is your line y is equal to x, because that's what we did. We made y equal to x, hence we could swap x and y around. And now our inverse, like I said, is going to be reflected about the line y is equal to x. So it's not going to be perfect, bear with me. So there would be your inverse. Oh, I just remembered, actually, the answer that they wanted there. They wanted us to write it as f negative 1x. Okay, make sure to follow all instructions. Okay. No. Okay. So even our sketch, there we are. We have the function f and its inverse. And they want to show all the intercepts with the axes. Okay, so like I said, the y-intercept is basically where x is 0. So if you have y is equal to 3 to the power x, anything to the power 0 will be 1. Okay, hence I said it is 1. So when x is 0, y is 1. And because this is the inverse, we swap x and y around. So this will be 1 and 0. And that is the only intercept. Okay, here the asymptote, the equation of the asymptote will be y is equal to 0. They didn't ask for it. This is just extra information. Here, the equation of the asymptote will be x is equal to 0. Okay, and that's basically that for 4 marks. Now 7.1.3, they say write down the domain of the inverse. So the domain is basically the x values that are applicable for this function. So if you look at this function, what are the x values that are applicable? I can tell you this. The negative x values don't apply to the inverse. You only have values from x being 0 up until infinity. But even where x is 0, remember this is the asymptote. So we cannot include 0. If you dare to include 0, it's going to be wrong. Okay, so basically our domain then would be just the values that are bigger than 0, because it goes just after 0 all the way to infinity. Or another way of writing it, you would have said x is an element of 0 all the way to infinity. Okay, either way it would work. So that is the domain. And now 7.1.4, it says write down an equation of g. Okay, so this is a new function. If the graph of g is the image of the graph of f after f has been translated 2 units to the right and reflected about the x-axis. Okay, let's go back. Let me just erase all of this and let's just understand what they are asking. All right, what are we doing again? So g is the image of the graph of f after f has been translated 2 units to the right. So we have a horizontal translation. Okay, so 2 units to the right, if f is 3 to the power x, 2 units to the right will just be x minus 2. I hope you know that. It is x minus 2. Now we are going to reflect that 3 to the power x minus 2 about the x-axis. Previously, when we started this, I showed you the reflection about the y-axis. How will the reflection about the x-axis look? Well, we're looking at this function, right? The reflection about the x-axis will look like this. Okay? And the equation thereof will be y is equal to negative 3 to the power x. That's it. Reflection about the y-axis, that would be y is equal to 3 to the power negative x. Hence, 3 to the power negative 1 can be rewritten as a third. Okay, hence I wrote it like that. So basically, our function here has been shifted 2 units to the right. So we say negative 2, not positive 2. Please don't make that mistake. And because we are reflecting it about the x-axis, it means we're going to put a negative over there. Okay, so basically, if I now write the full function of g, it's going to be negative 3 to the power x minus 2. Minus 2, shift to the right. Negative 3, it's reflected about the x-axis. Alrighty, I hope that was very clear. And that's basically it for 7.1.4. Now we can, and if you want to simplify this further, you can do that. That's if you really want to. What do I mean? Well, we have a negative 3 to the power x minus 2. Okay, this is the same as negative 3 to the power x times negative 3 to the power minus 2. Okay, but I wouldn't complicate my life like that. So let's just leave it as it is. And we have the negative 3 to the power x minus 2. Now 7.2.1, I see we have a different graph now. So 7.2 says the graph of h of x is equal to the root of 4x, okay, where x is bigger than 2 and it's drawn below. The graph of h passes through the point A, where we have the x coordinate as p, the y coordinate as 4. Okay, so I hope you see that this graph is actually a parabola that has been halved. Okay, so if you have a parabola, y is equal to x squared, and you get the inverse of it, you're going to have x is equal to y squared. And if you write it in terms of y, you're going to get root x. Okay, if you apply the root both sides. All right, so we can see where that comes from. Now let's get back to what has been given. Now it says for 7.2.1, calculate the value of p. If you have been given an equation, so you have h of x is equal to the root of 4x. If you have a point that's been given to you, then plug it in, okay, and see what that gets you. So the y value is 4. The x value is p. So you can see here that your only unknown is p. So if we square both sides, we'll get 16 is equal to 4p. And then now if we divide by 4 both sides, you can see that p is actually equal to 4. So you can just write for yourself that the coordinate of A is 4 and 4. And the last question, 7.2.2. It says, determine an equation for the inverse of h in the form y is equal to. So currently we have y is equal to the root of 4x. Now we're going to swap things around. So x is equal to the root of 4y. And in order to get rid of the root, we're going to have to square both sides. So you have x squared is equal to 4y. And because I want to write y by itself, I would say y is equal to a quarter x squared. All right. Just one thing to be aware of, this graph, it is actually applicable for values of x that are bigger than 0. Okay, actually you can even include the 0 because you can see the graph does start at 0. I don't know why it said just x is bigger than 0. It should be x is bigger and equal to 0. Okay, so that's a condition. We're not going to draw the graph where the x values are less. Okay, so what am I saying here? Let me just draw what the inverse will look like for you. They didn't ask for it. This is us being done. But we have our graph over here. And if we were to put our inverse, remember the inverse, we first need to put in our y is equal to x line. And then we can draw our graph. So basically, our graph would look something like this. Okay, and this is the only side that we're drawing. All right, this would be your y is equal to a quarter x squared. We're not including this part because the original function didn't include this part over there. Okay, so only on the right hand side are we drawing the graph. We're not including values of x that are less than 0. So that's why we have this condition over here that x has to be bigger and equal to 0. And this is it. We are done with this paper. Again, don't forget to like our videos and subscribe to our channel. Do tell your friends about this channel. This channel really helps a lot in terms of preparing for your exams. And yeah, anything else that you think we can work on, please do write in the comment section, because we are, after all, serving you and we want to ensure that our service is good.